Okay, boys and girls, good morning. Hope you're enjoying your second day off in a row. Like I mentioned in class, because of all the interruptions, we're starting to get this unit moving. So hopefully you watch these videos and have a good idea of what's going on when you show up tomorrow. So quick intro to logs. So first thing we need to understand are exponential functions. So these functions, as you can see, go very flat and then they grow extremely fast. Here's a table on the right to kind of demonstrate what is happening and how fast they actually grow, with this function y equals 2x. As you notice, there's a horizontal asymptote at y equals 0. I wrote here y question mark. I want you to ponder that question and have that answer ready for tomorrow. Why does this have a horizontal asymptote at 0? Next, the domain, all the possible x values go from negative infinity to positive infinity, so everything works. Now, here's the question. How would we solve for x? As you can see, x is up in the exponent, and we can't just divide and simply isolate it that way. We need another inverse operation. The example I put over here is you can see that 2x equals 16. To get x by itself, we just divide by 2 because that's the inverse of multiplication. So this is where logs comes into the picture. If we had something like this, 2 to the x equals 8, how would we solve if we just didn't know the answer? Obviously this answer is 3. That's trivial, but how do we know if it was a bigger number, something we didn't know off the top of our heads? And now this is how we would do it. So we would have to take the 2x equals 8 and rewrite it into log form. A lot of this unit, you're going to be rewriting things in log form and exponential form and be able to go back and forth between both forms. So this is a key skill you're going to need for the unit. So as you can see, I try to color code it so you can see where all the numbers and letters went and where do they go. So 2 is the base of the exponent. It's also the base of your log. Green is the answer of your exponential function, but it's called the argument in the log function. It's just a fancy name that they gave that spot in the log function. And then the x is the exponent in your exponential function, but it actually becomes the answer, and that's how we get it isolated by itself in the log function. Plug this into your calculator and find out the answer. Now, I was trying to find a calculator lesson online to show you guys, but I couldn't find a good one. So don't worry about plugging things into your calculator, because some of you have an actual log button on your calculator where you'll be able to enter the different bases. Some of you don't have it where you could change the base. So don't worry about entering the calculator now. We'll go over that in class. All right, so that was the first set of notes. Here's just some practice. Just pretty much rewrite it. That's all I want you to do, is be able to rewrite it, go back and forth between forms. So there's an example of what it would look like, and then there's another example of what it would look like, going from log to exponential and exponential to log. So do a couple of these problems and make sure you have the idea. So and again, down here, this will put y back up into the exponent. Again, just rewrite it. Don't worry about solving for anything yet. Okay, next, log rules. There's a couple of rules with logs that we have to know as well. So here are the three, the basic ones that we'll go over first. So if I multiply or if I add two logs with the same base, so b is the same thing, it's the same color, same number. I take the arguments and I add them or multiply them together. So I'm talking about this first one right here. So if I add logs with the same base, I can combine them and multiply their arguments. Now, where does that come from? Where the heck did they get that? If you think back when we work with exponents down here, if I'm multiplying something with the same base, I can just add the exponents. So here's the example. If I had x to the third times x to the fourth, my answer is just x to the seventh. So basically all I'm doing with logs is the reverse of that. So that's where that comes from. It's the reverse of what you would do if you were just adding exponents, because you were multiplying things with the same base. The next rule is if I subtract logs with the same base, I divide the arguments. And again, if I was doing that with exponents, I would actually subtract. And here's the example. X to the eighth divided by x to the third is really x to the fifth. So when I subtract exponents, or when I subtract logs with the same base, I can divide the arguments and make it one log. And again, it just comes from, it's the exact opposite we would do with the exponents. That's why they're inverse operations. Then finally, if I have an argument in a log that has an exponent, I can then take that exponent and bring that down to the front. Again, it's just another way of manipulating the function to make it look like how you want it to look, and then to be able to just have the argument by itself. So those are the 3 log rules we're going to go over for now. Under that is some practice. So as you can see, again, 10 is just 5 times 2. I can make it that. For example, the next one, 50. You do 10 times 5 would work. 25 times 2, whatever you want to do, just break them apart. Oops, hold on, let me erase that. Okay, so then the next one, they're adding, so I'm just they're adding, so I just multiply the 9x and 3y to get 9x divided by 3y, and I could simplify that to 3x over y. If you have multiple ones, like in D here, it's 25 times 2 times 4. Just keep going from left to right. And then here, again, just go from left to right. So the top one would go first, log 3 with 8 as the argument, minus log 3 with 25 as the argument. So again, you would go from left to right in that order, from top to bottom, left to right when you write it. These ones are a little crazy down here. So it says simplify where possible. So if I'm subtracting, that means I'm dividing the arguments. This is going to be 5 over x divided by 20 over x. So if I write that horizontally, I could see 5x divided by 20x. Now how do I divide fractions? I keep, change, flip, which means I keep the first one the way it is, change the division to multiplication, flip the second one. And because I did that, just like last unit, now we could do some simplification. So I could simplify the 2x's here. I made them both 1 because it's just x over x. And I could simplify the 5 and 20 as 1 over 4. So my final answer simplifies to log base 10 argument 1 over 4. Again, just another way to test your skills of simplifying with rational equations or expressions. So that's it. Go through some of these, do a couple, be ready to work with these tomorrow, and I'll show you how to put them in your calculator and actually find answers. So if we could have that ready to go, it will give us a pretty good jump on this unit. Much better jump than we would have had if we didn't do any of this, showed up for a day 5 tomorrow in a very short period, and then had a weekend. So please go through these. Please have an idea of the concepts, and any questions, let me know. All right, enjoy the day, guys. Bye.